These notes are on G.1 Principles of Geography, and this is on G1A and G1B. The learning objective for G.1 is to explain how geographers use maps and data to contextualize spatial relationships and examine the human organization of space. So for G1A, G1A is about how maps represent space, and the essential knowledge is that maps convey representations of space, place, and location through symbols, keys, scale, and other manners of representation. So on your Cornell notes, you're going to record the notes that will be coming up. We record that on the right-hand side. When we're done with all that, then we will go back and write level 1 and possibly some level 2 questions to help us process the information, like asking what something means or what the difference is between something, or what's the difference between large scale and small scale, things like that. All right, let's begin. So again, these notes are written on the right-hand side. So scale is used to show relationships, between measurements on a map and the actual distances they represent, like a ratio. So you see on the image, we have two different scales. One's in both kilometers, kilometers and miles. The other one's just in miles. So if two cities were 200 miles apart, we would not have a map that was 200 miles wide. We would use a scale. So let's say an inch was 100 miles. So then when we measured on the map, 2 inches would be 200 miles. There are two types of scale. So there's small scale and large scale. So a small scale map shows a large area but with little detail. So looking at the map on the right, you see that this is a very large area, but we don't get into the street view. So it's a small scale, it shows small detail. A large scale map is the opposite, and that's the map on the left. So a large scale map is going to show a small area, it's zoomed in, but it has lots of detail. Think about using your GPS. Symbols represent information on the map, and they're explained on a map key, which is also known as a legend. So here on this very childish map, we see that anytime we see flowers, those flowers represent a garden, and anytime we see water, that represents a duck pond. Next on our notes, we have compass rose. So compass rose, or a north arrow, is used to orient location. So sometimes when we're looking at a map, we need to know which way is north, which way is west. So we're going to have either a compass rose or a north arrow. So looking at this map of Canada, we have a compass rose, and if you notice, north is slightly tilted towards the right. We also have a scale. And we also up here have a legend or a key telling us what each of those colors on the map represents. Geographers also used grid systems. So grid systems are used to identify absolute location. So absolute location is a unique location on a map, similar to your home address is a unique location for your home. So latitude and longitude is the most common type of grid system on a map. So latitude lines are these parallel lines that go horizontally around the Earth's surface. The equator is 0 degrees latitude, and then these lines are parallel, never touch, all the way to the North Pole, which is 90 degrees north latitude, and all the way down to the South Pole, which is 90 degrees south latitude. To intersect those lines, we have lines of longitude, and they go long. Lines of longitude touch at the poles. They are the widest at the equator, and they go vertically from pole to pole. And the two main lines of longitude are 0 degrees, which is the prime meridian, and that divides the Earth into to western and eastern hemispheres. And then on the other side, you have the international date line. Sometimes, instead of latitude and longitude, letters and numbers will be used. So letters on the top, for instance, and numbers on the left. And that's usually used for things like road maps. There are different types of maps. For example, there's physical maps, as shown here. This shows rivers, plains, mountain ranges, lakes. You can have a political map. Those show different states or territories, and they're usually shown by color. This one also shows capitals and major cities. And then you have special purpose maps. So for instance, population density map, that is a map that is special. Its purpose is to show population density for counties. So each different map shows different information in different ways depending on the purpose of the map. So in next class, we're going to be looking at images and mostly focusing on scale. So I want you to just preview these images. So in source 6, this is an image taken from a satellite of New York City. And then this is somebody at an overpass just taking a picture with their camera, also in New York City. Then for source 8, this is an aerial photograph, so photograph taking from the sky of New York City at night. And then this is also an aerial photograph of the daytime of New York City streets. And again, difference in scale, large scale, small scale, what kind of specific information, details do we see or not see. All right, so next we're going to look at G1B, and this is the purposes, approaches, and context of maps. And the essential knowledge here is that maps reflect political and cultural context and prioritize, exclude, or distort information to serve a variety of purposes. So you learned last year about bias. Maps also have bias depending on who is making the map or who's paying to have the map made and what information are they trying to tell us, and are they taking any information out either to trick us or because it's not necessary for us to know for their purpose. So again, you're going to record your notes on the right side. Anything that is typed on the screen you're going to write, and then eventually we'll do those questions on the left. Okay, so maps are not accurate representations. So we know this already because the Earth is a three-dimensional object, it's round, and maps are two-dimensional papers or images on a screen. So maps can emphasize, they can exclude, or they can distort data to serve a purpose. Information can be influenced by the political and or the cultural context in which the maps are made and their intended use. So looking at this image on the screen, this is a map of the world. If you notice, here's the compass rose, north is facing down. Most of the world maps that we see has the United States right here in the center and Europe right to our right. And that's because those maps for the United States, we want to focus on our nation. But here, this map is probably for a country like Australia. And so because of that, they want the same thing, to focus the eye on their country as being more front and center. So maps can absolutely emphasize or distort information. Map projections also distort information because it's a two-dimensional representation. It's flat of a 3D Earth, a 3D Earth. So some examples of projections, and there's dozens of projections, are Mercator, Robinson, Gall-Peters, equal area, and conic projections. And looking at this image, the yellow is the Earth using the Mercator projection. Notice how big Greenland is up here on the top. Greenland is not that big. And then the blue is the Gall-Peters projection. And notice how the Gall-Peters projection stretches out the land. So both of these are just map projections that are used, and neither one of them accurately represent the Earth as it really looks. And so in class, we're going to be looking at two sources and looking at how maps can exclude or distort information depending on their purpose. So the first map is of the subway system in Washington, D.C. And so we're going to look at that and look at what information is being emphasized, what other information is on there that might be helpful. And then we're going to compare that to a similar map So source 11, we also have those metro lines, that's what all these colors are, but now we have that overlaid on a DC street map. And so we're going to look at, is the information shown the same? What would be the purpose of each of these maps? Those are all of the notes that we have for G1A and G1B. I'll see you in class.